Terima kasih banyak sahabat saya Dr. Wan atas penjelasan. So insyaAllah saya akan membentangkan kertas kerja dalam bahasa Inggeris kerana material telah berada dalam bahasa Inggeris, disediakan dalam bahasa Inggeris. Assalamualaikum warahmatullahi wabarakatuh. Very good morning. First of all, I would like to thanks to the organizer, MACD, for the invitation. So today I will be talking on two parts. First on SDG and disaster risk reductions, on how geospatial technology, geospatial community can contribute into this international framework. So as a content, as a guideline, I will be sharing about the SDG, Agenda 2030 for Sustainable Developments, and perhaps on the disaster risk reductions, the Sendai Framework 2015-2030, and perhaps we see how the geospatial technology, in particular, all the sensors, all the data analytic can help those framework, especially in achieving the target and goal set under SDG and DRR. And the third one, I will be sharing some of the local case study, perhaps some of the project that I was involved. And perhaps on the mainstreaming DRR into development planning, some of the local project in Khamarrul Highland, in Sabah, and I will end up with the concluding remarks with some of the completed project funded by Republic of Korea and submitted recently to the Germany. I will skip some of the slide. I was given about 20 minutes, but before I start, I would like to call all the young scientists, all the young researcher, young officer. If you are intent to apply for these memberships, you can do so. You just Google it, this Global Young Academy. I was invited to this membership recently. So I contribute part of this presentation to this society. So as a start, it's mentioned in my abstract, about 10 out of 17 SDG with 25 targets are dedicated or related to the disaster risk reductions. So during my talk today, I would like to look into the link, target and goal set under SDG, and what kind of targets and goals set under Sendai framework, which can be, the geospatial technology can contribute significantly. And talking about the climate change, rapid urbanizations, that's tell us, these are perfect times to use all the advanced technology, of course, geospatial technology, providing a good data set. So then it can improve our understanding. So by looking at the slide, you can see on the left side, it's a Sendai framework for disaster risk reductions. So technically speaking, they map all the targets set under Sendai framework. And on the right side, some of the example how the goal and target, so they match. So technically speaking, those international framework, they are communicating, they are completing each other. So now I would like to focus, talk on how the geospatial technology can play a role, and as a scientist, as a government officer, perhaps, we can also contribute indirectly into this achieving this goal. And also by looking at the flow from 1990, all the international framework, especially in the disaster risk reductions until 2015, launched in Sendai. There are a number of targets should be achieved, and by 2020, all the national, the governments should report what would be the current status of all the targets. So by looking at the Sustainable Development Goal Report 2017, which was released, and it specifically mentioned about the geographic context. So it specifically mentions about the use of geospatial technology. Technically speaking, they are interested on the high quality, timely, reliable data. So of course, we are talking about Earth observation, geospatial informatics, and now the recent trend, they are interested on the big Earth data analytics. That's something we have to explore in the next 5 years and 10 years. And at the United Nations level, there's a this a big shift between, a group of statistics and a group of geospatialists. They are working together. They launched in July 2017 to monitor the target, goal, and also all the indicators under SDG. So this the mapping that they did. Well, they put it the geospatial data, geospatial informations, and they map based on the 17 goal and these more than 167 targets under SDG. That's something interesting. So if we carefully look into the goal, targets, indicators, that's something we can contribute a lot. I will go in detail in next couple of slides. So last couple of years, they have released this thematic, how they map this SDG 70 goal, and they did mention about the disaster and environmental impact monitoring. So I will narrow down the talk today. These sessions focus more on the disaster aspect and how our society can contribute. So on the left side, it shows all the sensors. I think, coming from the space until the underground situations. And on the right side, it shows about the data analytic. I think now the trend more towards how we use the data, how we communicate the output collected from the field, communicate with the policy makers. We have to convince the decision makers. So technically speaking, a lot of modern advanced geospatial technology is underutilized. At least in the context of disaster risk management. So that's something we would like to see, how this community can play a role. So let's have a look some of the World Risk Report, where we are, Malaysia in particular. Do you know what is our rank? Back 2016, I will share some of the figure. So it's at the world level, they put it this very low until very high. They map all these informations, and of course they use geospatial data. And some of the keywords I will share later about vulnerability, susceptibility, exposure, risk information. There's something interesting in this topic. And of course, we are at rank 86, not bad, compared to our colleague in Thailand. But interestingly, I would like to show you, if you look at on the slide, look at Japan, look at Philippines. So these are most 15, countries exposed to the disaster. And look at next figure, where's Japan? In the context of 15 countries that are most at the risk worldwide. They are gone. They are not in the 15 list. What is the message here? Even though the country is lying on the very high exposure level, but with a certain, a control, structural and non-structural measure, all the preparedness level, it can reduce the risk. So that's the message from this figure. So at least our colleague from Japan, of course, they are now facing a huge flooding. And if we compare to the other developing countries that are facing similar issues. Let's move to the data. So it was stated, access to the information is critical to successful disaster risk management. What it means, you cannot manage what you cannot measure. Some of the disaster managers, sorry to say, they made a lot of assumptions. Well, perhaps not based on the technical scientific data to make certain decisions. So this is a strong message from UNHCR, United Nations Office for Disaster Risk Reductions. We have to deal with data. I think our community, at least geospatial community, can play a major role providing a good data. So talking about Malaysia in particular, in 2040, they're predicting about the immunization rate up to 85%. With the population rate up to 46 million people. So there's an urgent need to monitor our current developments. So we are not talking about now, we are talking about the future as well. And, technically speaking, I made these statements, assessing environmental and socio-economic impact is still very challenging. And even though in the context of the use of advanced geospatial technology, spatial and temporal information, it still remains elusive. That's something we have to work together. And I will talk in the rest of the slide on the aspect of risk, vulnerability, on how this multi-hazard and risk information can help the future development planning. Let's move to these standard equations. Well, we use these equations to develop the 46 million project managed by the Mineral and Geoscience Department back last 3 years ago. Well, they are talking about spatial. You see they are talking about temporal. It's all the data is coming from this society, and they are talking about the element at risk. I will be explaining about the element at risk in a moment, and also the vulnerability aspect. Of course, at the end of the multi-hazard risk assessments, they come out with a map. It's just a perceptions, you know, the way how sophisticated the system, how well intelligent the algorithm. At the end of the story, it's just a map. So how the map communicate with decision makers is very important. So we developed the national methodological in terms of producing hazard and risk map, at least in the context of sediment-based disaster. So we use a lot of data, especially the green box on the A box. A lot of things you can, well, at least we can contribute to the spatial community. And into the modeling, into the susceptibility modeling, hazard modeling, risk assessments, I believe, well, there's a strong groups can really look into how much basically we can quantitatively assess those informations. So some of the methodological aspects that we developed for JMG project, well, 40% of the total budget goes to the data collections, data acquisition we use to improve the data modeling in order, well, at least we can convey our decision makers with this good, reliable hazard and risk map. So if you look at how, well, why they use LiDAR for such a big project, of course, if you look at the trend, global trend 2013, 2020, they did predicted about the use of this global LiDAR market. I think this justifies some of the investment made by the federal government. Now I would like to show some of the, June 2015, we did a study in Kundasang, in particular after the major earthquake in Kundasang. That shows how the geospatial technology can well, straight away, even though it's very expensive, technically speaking, but it gives a lot of input, particularly to understand the root causes, risk. Well, I skipped some of the informations today because of the limited time, and we did fly a couple of months after the debris flow take place in Mount Kinabalu. It goes to this Sungai Mesilau. And of course, we use the most advanced, helicopter-based airborne LiDAR. At that time, we come out, well, at least 3 years ago, that can be one of the most highest point cloud density in Malaysia, used for the disaster risk management. And in fact, they did mention in the landslide-induced sediment production about a poor data available in the top. So let's move to some of the data aspect in terms of the vulnerability cities in Malaysia. So we use a lot of data to convince at least used by the town planners, urban planners, how to make a good decisions. One of the public document used is a Khamarrul 2030 local plan. You can have a look. Perhaps one of the good suggestions how we can really utilize advanced modern geospatial technology and all the data analytics to help to have a better development planning. So moving from multi-hazard risk assessments into resilience. So there's equations that we are currently embarked. So that's something interesting. Those who are interested to look into the disaster resilience, we would like to adopt these equations and look into the human activity and time. We also I have also developed this framework for the sediment disaster management. A lot of aspects which can be contributed directly from geospatial aspect. And talking about the element at risk, on the left side, a lot of objects aspect need to be monitored, maps, characterized, and also a skill of analysis. In terms of the small scale, detailed scale, I think, well, technically speaking, we are supposed to be one of the major stakeholders in providing those data. And the recent study that done by CIDB CRIM, and I'm also involved in this project on look into the sustainable and resilience for critical infrastructure. So I have about 5 minutes to go. What I'm going to do, there are two major projects from Korea and German. I will glance and then I will go directly to the conclusion remarks. So this example from the Korea project that was 2 months ago completed, funded by Republic of Korea. We did the study together with the Smart Selangor. They have a 12 pillar. So one of the pillar is talking about smart disaster management. So we developed the meta model for geospatial multi-disaster prototype system. We developed and we tested and we used in this disaster simulation day that was, well, I think remarkable. It's a first ever landslide disaster simulation ever recorded in this country, done at least this disaster. Well, I have this video. I'm not going to go the whole things since I'm running out of time, but something interesting, there's no sounds. It's supposed to be sound here. But what we did in this particular project is basically we identify some of the local leaders, local champions to use our sensor, to use our system that we developed. So technically speaking, we are promoting a bottom-up approach instead of we at the federal level, at the state level, well, come up with our own system. So we have to understand the level of needs and requirements by the local community. So this slide, you can get it from the community. You can have a look the whole video. This project done together with Malaysia Civil Defence Force and Selangor State. So what we are interested in basically is to promote public help, mutual help, and self-help, at least in the context of Malaysia, not only on the landsliding, flooding, but also on earthquake related. So move to the German project. We come up with this proposal submitted for the 8 years project under the term of risk cities. Before, during, and after, we are promoting a 4-cycle disaster preparedness, prevention, mitigation, as well as the recovery side. And we come out with this, with the German colleague, we designed for the big data platform for disaster risk reduction. It's still at the conceptual process. I think this is the first time I publicly presented that technically speaking, there will be an 8 years project with a group of scientists from Germany, how we can use a big data, big earth data analytic, use all the sensors, data, and information collected. So we design especially all the disaster that happening in the city, at least in the city context, and we improve the right side. If you look at the right side, I think this is the most critical one. How do we convey, how do we communicate with the decision makers? Very important in terms of the risk communications. I'm come to the end of my presentation, so this is a list of the multi-hazard and disaster risk management system in terms of the technical data and decision makers. We have, well, I think explore a lot of things. Those who are interested, we can have a chat about that. And also about the future, we did improve that, and some of the local research involved how do we cope with the current multi-hazard and risk assessments in the context of land use changes, climate changes, you know. So that's something we can do that on the scenario, climate, land use, and socio-economic. So that would be something interesting. So I come to the end of the last 1 minute. So there are still 2 slides. So this is a Sendai Framework for Disaster Risk Reduction 2015-2030. You are part of the journey. I think we can play a role, how we can contribute, especially on the first priority. On the left side, understanding disaster risk. So they are talking about mapping, they are talking about monitoring, characterizing, well, early warning. That's a lot of things we can contribute, of course, by using all the geospatial data. And come to the last 30 minutes, this is my conclusions. So I think there's a synergy between SDG and DRR. So they are talking about the same directions. We are not just talking about now, I mean reduce current risks, but also we are talking about preventing future risks. I think there's a significant role given by the geospatial groups, at least those who are in this huge wall. then, well, we can contribute to the success of achieving Agenda 2030 for the development goal, and also reducing disaster risk in the near future. With that, I think I close my talk. Thank you very much for your attention. Assalamualaikum warahmatullahi wabarakatuh.